Welcome to the second session of Module 1. Course objectives are this course will enable students to understand various sources of IoT and MTM communication protocols, describe cloud computing and design principles of IoT, become aware of MQTT clients, MQTT server and its programming, understand the architecture and the design principles of WSLs, and enrich the knowledge about MAC and routing protocols in WSLs. Course outcomes are at the end of the course, students will be able to describe OSI model for the IoT MTM systems, understand the architecture and design principles for IoT, learn the programming for IoT applications, identify the communication protocols which best suits the WSLs. In this session, we just understand the various aspects of IoT, technology behind the IoT and steps behind the IoTs we are going to discuss in this session. Technology behind the IoT. So the entities like hardware, IDE, protocols, those will provide a diverse technology environment and are examples of technologies. First one is the hardware. So we can use Arduino, Raspberry Pi. We may use Intel Galileo, Intel Edison, ARM Mbed, Bosch XDK 110, BeagleBone Black and wireless SoC. Next is integrated development environment, IDE and software, which will enable developing device software, firmware and APIs. We can use Eclipse IoT stack, Sense, ThingWorks, everything. We can consider the software like RIoT OS, ThingSquare Mist firmware, Eclipse IoT. Next entity is embedded devices, MTM communication protocols. So we can use CYAP and RESTful HTTP, MQTT, XMPP, and for communication we can use RFID technology or NFC, 6 LOWPAN, and we can use ultra wideband. We can use Zigbee, Bluetooth LE, Powerline Ethernet, and LPWAN. Next is network protocols. We can use Zigbee, RPL, IP version 4, IP version 6, UDP. The technology we can use Wi-Fi and WiMAX, 2G, 3G, 4G or 5G. And the next entity is software platforms, internet or cloud platforms, namely Xively, Nimbits, TCS Connected Universe Platform, OpenHAB, AWS IoT, IBM Bluemix, Cisco IoT, IOX, and for everything, and we can use server. Next entity is analyzing and visualizing. So this is for analyzing data, streaming data, event streaming data, and it is descriptive, prescriptive, and predictive analytics we can perform. We can perform data visualization, analytics, and machine learning, in that learning ability to learn continuously from data and the ability to drive actions, applications, business processes. We can use machine learning algorithms, for example, GROK from Numenta Inc. So these are the entities we can consider. It is involved in IoT, hardware, and IDE, that is integrated development environment, and protocols like RPL, COAP, RESTful HTTP, MQTT, XMPP, extensible messaging and presence protocol, that's for XMPP, that's the expansion. And for communication also we can use the Ethernet, Powerline Ethernet, RFID, NFC, and 6LoWPAN, UWB, Zigbee, Bluetooth, Wi-Fi, WiMAX. We can use 2G, 3G, 4G, and we can use the network backbone like IP version 4, IP version 6, UDP, and 6LoWPAN. We can use the software, IoT OS, Quantic OS, Things Square, Mist, Firmware, Eclipse IoT. Inter-network cloud platforms are data centers. So in that we can use Sense, ThingsWorks, Nimbits, Xively, OpenHAB, AWS IoT, IBM Bluemix, Cisco IoT, IOX, and for everything Azure, TCS, CUP. So these you can use for internetwork cloud platforms. And machine learning algorithms and software. An example of machine learning software is GROK from Numenta Inc. that uses machine intelligence to analyze the streaming data from clouds and uncover anomalies. It has the ability to learn continuously from data and ability to drive action from the output of GROK's data models and perform high level of automation for analyzing the streaming data. So next we are going to consider the steps behind the IoTs. So your first step is a device platform consisting of a device hardware and software using a microcontroller or SoC or custom chip. and software for the device APIs and web applications. And second is step is microcontrollers. For connecting and networking. So connectivity protocols and circuits we can use that will enable internet networking of devices and physical objects called things, and enabling the internet connectivity to remote servers. And the third step is a server and web programming, enabling web applications and web services. And the cloud platform enabling storage, computing prototype and product development platforms. And the online transaction processing, online analytics processing, data analytics, predictive analytics and knowledge discovery, enabling wider applications of an IoT system. So these are the steps behind IoTs. Device platform consisting of device hardware and software. You can use microcontrollers or custom chips, software for device APIs and web applications, connecting and networking, server and web programming, cloud platform for storage and computing, and data analytics, visualization and machine learning. Server end technology, if we consider, IoT servers are application servers, enterprise servers, cloud servers, data centers and databases. Server offers several software components like online platforms and device identification, identity management and their access management, and component like data acquiring, aggregation, integration, organizing and analyzing, and use of web applications, services and business processes. So those are server end technology. And this is the reference I have used, and this is the textbook also for the IoT and WSN. The textbook is written by Raj Kamal. Textbook name is Internet of Things, Architecture and Design Principles, and it's published by Macro Education. And so in this session we discussed about technology behind the IoTs. Thank you.